Okay, today we're talking about sigma notation, the use of sigma notation in the context of arithmetic series. Now, sigma notation goes like this. That symbol there, which is not very well drawn, is the Greek letter sigma, it's uppercase sigma, that basically means sum or total. We've probably used it before when dealing with, when talking about statistics. So it's really just sum or total. What this is asking us to do is evaluate, so find an answer to, work out, etc., or find the value of this series here. Now this is arithmetic because it's in linear form. By linear form, I mean that there's no n squared anywhere or n to a higher power. There's just an n there with a coefficient of 3 plus 1. If you were to treat that as a, in linear algebra as a line, you could map that and it would be a line with a gradient of 3 and a y-intercept of 1. But anyway, it's telling us that every term, or each term, goes up by 3 every time. It would in fact draw a line, strictly speaking, because you'd have integer values, so it'd be a series of dots going up like that. So what we've got going here really is a series, and we could give you some idea of what it looks like in its infancy by substituting the values of 1 to 18, I'm not going to go that far, into our rule. So our series really looks like this. The first term, n equals 1, is 3 times 1 is 3, plus 1 is 4. I've already said that it's going to go up by 3 every time, so I don't even need to substitute n equals 2 into there to find the second term. I mean, I could. 3 times 2 is 6, plus 1 is 7. But I do notice that if I just add 3 to the 4, I get 7 anyway. So it's following that linear pattern. And the next one would be 10, and so forth. Okay, so that's what our series looks like. Now, we don't really have to know that to evaluate our series. We don't have to know that. It's a series. I'm evaluating this. What do I need? How about I start with a formula? How about I start with this formula for the sum of an arithmetic series? N over 2, A plus L. Once I get, again, I just know what it is I need to make this work. Well, I need to know a value of n. For n, I need to know a value for the first term, and I need to know the value of the last term. Remember the other formula, the longer one? I could use that, but I think you'll find this one's quicker. N is quite clearly, that's right, it's 18, because there's 18 terms in my series, 1 to 18. There are no particular traps there. A is equal to, staring us in the face, 4. Now the last term, I don't see there, but I can find it out readily by letting n up here equal 18. The 18th term is the last term. So 3 times 18, 3 times 20, 60, there's a quick way of doing it, take off 6, 54, isn't it?
54.
Plus 1 is?
55.
55 is correct. So by substituting those values into my formula, I will have evaluated that series. Okay, so the sum of the first 18 terms equals, n we said was 18, so that's, 18 divided by 2, bracket 4 plus 55 for L. Okay, so that's equal to 9 times 59. If it was 9 times 60, I'd be 540. Take 9 off that, it is 531. So S18 equals 531. Can you cut, please? Just press the red button.